Imagine satellites failing, cosmic radiation pouring into the atmosphere, and the climate entering an unpredictable dance. The question echoes like distant thunder. Are we prepared for what's to come? Earth's magnetic field is generated by currents of liquid iron in the outer core, thousands of kilometers beneath our feet. Like a giant dynamo, it creates a shield that deflects charged solar particles, protecting both life and technology. But this field is not fixed. Throughout history, it has reversed its poles, north becoming south and south becoming north, on average every 250,000 years. The last reversal occurred 780,000 years ago. Now, the signs suggest that a new one may be approaching. Since 1830, the field has lost about 10% of its strength. The magnetic North Pole, which used to be in the Canadian Arctic, is racing toward Siberia at 50 kilometers per year, a pace never seen before. What's happening? Imagine Earth's core as a turbulent ocean, where currents of molten metal swirl in chaotic patterns. When these flows fall out of alignment, the magnetic field weakens, setting the stage for a reversal. During this process, which can take anywhere from 100 to 1,000 years, the field doesn't disappear but becomes unstable, with multiple magnetic poles appearing and vanishing. It's as if Earth loses its rhythm, leaving the atmosphere vulnerable. Scientists at the Goddard Research Center in the United States are monitoring these changes with satellites, but the future remains uncertain. Picture the impact. A weaker magnetic field allows cosmic radiation, high-energy particles from space, to penetrate deeper. This could damage satellites that support communication, navigation, and weather forecasting. In 2003, a solar storm already caused failures in satellites and power grids. Now imagine this on a larger scale, with GPS systems disrupted and flights being redirected. On the surface, the additional radiation could increase health risks, especially for astronauts or passengers on flights at high altitudes. And the climate? The magnetic field influences atmospheric circulation. A 2020 study suggested that past reversals coincided with abrupt climate changes, such as prolonged droughts or heavy rainfall. History gives us clues. 42,000 years ago, during the Laschamp reversal, the magnetic field dropped to 5% of its normal strength. Fossil records show that species faced environmental stress, and caves in Australia hold traces of an unstable climate. Today, with 7 billion people dependent on technology, the challenges would be even greater. Think of Ana, a farmer in rural Brazil, who uses apps to predict rainfall. If the satellites fail, she could lose her crops. Or consider Miguel, a pilot who relies on GPS to cross the Atlantic. Without it, safety would be compromised. Science is at work. Researchers in the United States and Europe are using supercomputers to model the behavior of Earth's core, attempting to predict the pace of the reversal. Magnetic observatories, like the one in Hermanus, South Africa, track changes in real time. But predicting is difficult. The core is a mystery, as distant as the stars. Meanwhile, engineers are working on satellites more resistant to radiation, and governments are discussing plans to protect critical infrastructure. The key lies in preparation, understanding the risk and acting before it catches us by surprise. Visualize a world during the reversal. Auroras glowing even in the tropics, a light show that fascinates but signals a field in chaos. Satellites flickering in the sky, some falling in silence. Cities adapting, humans relearning how to navigate with compasses and maps. But also imagine resilience, scientists collaborating, communities coming together, technology evolving to face the challenge. Earth has been through this before, and humanity has always found ways to move forward. We are on the brink of an event that reminds us how small we are in the face of the planet's forces, but also how capable we are. The magnetic reversal is not the end, but an invitation to rethink our relationship with Earth and technology. Will we ignore the signs or use this moment to build a stronger future? The choice is ours, and time is running out. Thank you for watching. If you enjoyed it, leave a like, and we'll see you next time.